Greetings. Hello, everyone. Welcome to our presentation. In today's presentation, we will talk about MLP Topology Workbench. This project is written by our team that consists of myself, and there is Ajeng and Ropi. Now, let's continue. What is MLP Topology Workbench? You might ask. It is a web-based software application that is used to process and learn artificial neural networks. This application program will execute learning and gain the optimum weights for each nodes in the artificial neural network. The process of ANN in this particular application is evaluated by the score of MSE, or short for mean squared error.
This picture you see below in the interface of the MLP topology software.
Okay, next. We want to demonstrate how to use this application by implementing an example training. We will divide this implementation into 5 different sections.
In this topology tab, you will see everything that you'll need regarding the structure of the neural network or models as we desire. We could change the structural configuration in the bottom half, and those changes in the structural configuration can be seen in the top half of the interface.
In our example, we're using an diabetes dataset that consists of 20 input, and we are into hidden layer that consists of 6 neurons use the plus button. The output of this dataset is only a binary class, so we only reset one output layer.
Okay, next. This step was primarily created to produce commands for the multi-layer perceptron C implementation. So basically, you can do the tests you did in the topology tab, but without the visualization in this command section.
In this command tab, we can see the current state of the training by its total iteration or epochs, mean squared error, and adjusted weights, as you can see below.
For us to start implementing our training with this application, make sure we have a clean dataset to work on.
Next, to load your dataset, click the red highlight button.
Then, after you click the red button, paste your dataset. Make sure it's already on the CSV format, and make sure that you check the structure created earlier so it has the same number of inputs, hidden layer, and output. After pasting your dataset, hit the Update Parameters button.
Next, we move on to the training tab on MLP Topology Workbench. The train tab is where we want to train the dataset from the structure of the neural network that we configured before.
Next slide. As you can see on the top half interface, there are the input number of nodes, editable weight, outputs, and an MSE indicator. To start training, hit the iterate button, and everything in the structure is updated at each iteration, and the behavior of the mean square error. MSE along epoch can be inspected by the vector gauge at the right. The iteration of the training can be stopped by marking the interrupt option, and you can see the change of weight from each iteration or epoch. If you need to resume training, press the random button to assign all of the networks weight small random value between 0 and 1.
Now, it's time for me to explain how to save your training data from this application.
If you are satisfied with your train model and its result, you can save them by click the save button. After click the button, it takes you to the comment tab. The numbers in the comment tab are the representation of the weight from your train model. It can be used in another software to handle the weight.
Next slide. As you can see from our explanation on demo of MLP Topology Workbench, compared to Python, MLP Topology Workbench is easier to use by less experienced user. But there are some features that lacks options to customize our model further when compared to Python. We also find it difficult to do more advanced model improvements, unlike using Python, which has many libraries to perform data processing, which can make the model more powerful and resulting in a better overall performance.
That's it from us. Thank you for your time and attention. We will see you in another occasion.